I've been studying the James Webb Space Telescope images that NASA quietly released last year, and what I found challenges everything we thought we knew about cosmic evolution. These aren't the pretty nebula photos they promote. These are the ones showing galaxies 100 times brighter than theoretical studies predicted, existing when the universe was barely 280 million years old. There's a growing chasm between theory and observation that demands we ask whether our models of the universe are fundamentally broken. January 30th, 2026. The first images came back from Webb's latest deep survey, and the data streams in from a patch of sky no bigger than a grain of sand held at arm's length. The astronomers expected to see faint smudges, distant galaxies barely visible against the cosmic background. Instead, their screens lit up with something impossible. Blazing across the infrared sensors was galaxy MOEM Z14, a brilliant beacon of light from just 280 million years after the Big Bang. To put that in perspective, if the entire history of the universe were compressed into a single year, this galaxy was already shining brightly by January 8th. The galaxy spans about 240 light-years across, 400 times smaller than our Milky Way, yet it's pumping out light at an intensity that should be theoretically impossible for its age. The comparison is stark. You're looking at a newborn baby who's already 6 feet tall and speaking fluent calculus. That's essentially what Webb found. MOEM Z14 belongs to a growing group of surprisingly bright galaxies in the early universe, 100 times more than theoretical studies predicted before Webb's launch. These aren't measurement errors or cosmic flukes. They're systematic violations of everything we thought we knew about how galaxies form. The Standard Model tells us that after the Big Bang, the universe spent its first few 100 million years in what astronomers call the Dark Ages, a period when matter was slowly clumping together under gravity's gentle pull, eventually forming the first stars and tiny proto-galaxies. These early systems should be small, faint, and chemically primitive. They should be struggling to ignite their first generation of stars, not blazing like cosmic lighthouses across billions of light-years. But when Webb's spectroscopic instruments dissected the light from these ancient galaxies, they found something even more disturbing. These galaxies show high amounts of nitrogen, an element that requires multiple generations of massive stars to live, die, and explode as supernovae to produce. With galaxy MOEM Z14 existing only 280 million years after the Big Bang, there wasn't enough time for generations of stars to produce such high amounts of nitrogen in the way astronomers would expect. The MIT astronomer leading these discoveries, Rohan Naidu, put it plainly. With Webb, we are able to see farther than humans ever have before, and it looks nothing like what we predicted, which is both challenging and exciting. That phrase, "nothing like what we predicted," keeps appearing in research papers as Webb continues to shatter our cosmic timeline. Those blazing early galaxies were just the beginning. 3 months after MOEM Z14 shattered our understanding of galactic evolution, Webb's deep field surveys revealed something even more unsettling. The cosmic web itself was forming billions of years ahead of schedule. According to our models, 830 million years after the Big Bang, you should see scattered pockets of matter slowly clumping together under gravity's patient pull. Instead, Webb discovered a thread-like arrangement of 10 galaxies existing at that epoch. This wasn't random cosmic debris, it was a 3 million light-year-long structure anchored by a luminous quasar, a fully organized filament of the cosmic web that shouldn't exist for billions more years. The implications hit hard. Galaxies gather together not only into clusters, but into vast interconnected filamentary structures with gigantic barren voids in between. This cosmic web started out tenuous and became more distinct over time as gravity drew matter together. The key phrase there is over time. We're talking about processes that should unfold across cosmic epochs, not cosmic moments. Yet Webb keeps finding these impossible structures. The James Webb Space Telescope discovered a massive chain of 20 galaxies in the early universe, a megastructure nicknamed the Cosmic Vine that swoops through space in a bow shape, estimated to stretch more than 13 million light-years long and about 650,000 light-years wide. Our entire Milky Way galaxy could fit inside this structure's width 130 times over. The Cosmic Vine represents something that fundamentally breaks our timeline of cosmic evolution. It's significantly larger than other galaxy groups observed so early in the universe's history, adding it to a growing list of surprisingly huge structures in the early universe discovered by JWST. The researchers found the vine appears to be on its way to becoming a galaxy cluster, one of the most massive gravitationally bound structures in the universe. Here's what keeps me awake at night studying these images. The cosmic vine has an estimated mass of about 260 billion solar masses and is still growing. That's not just a big number. It's a mass that represents hundreds of billions of years of gravitational accumulation compressed into what should be the universe's first few 100 million years of existence. It's like finding a 1,000-year-old oak tree in a forest that was planted last Tuesday. The pattern emerging from Webb's observations isn't just challenging our models, it's systematically demolishing them. We found massive galaxies when we expected cosmic toddlers. We found organized cosmic web structures when we expected scattered matter. We found chemical complexity when we expected primitive simplicity. Each discovery builds on the last, creating a cascade of evidence that the early universe operated by rules we never wrote in our textbooks. The filament will eventually evolve into a massive cluster of galaxies, much like the well-known Coma cluster in the nearby universe. But that eventually assumes these structures are still forming. What if they're already formed? What if the cosmic web was essentially complete when the universe was barely out of diapers? That possibility doesn't just rewrite cosmology. It suggests we've been fundamentally wrong about how matter, energy, and time itself behave on the largest scales imaginable. After seeing the cosmic vine's impossible 13 million light-year span existing when the universe was barely formed, do you think we're fundamentally wrong about cosmic evolution? Or could there be physics we haven't discovered yet? Drop your answer in the comments below. But these massive early structures are just scratching the surface of what Webb has revealed. But the structural impossibilities were just the beginning. 4 months after Webb revealed those ancient galactic megastructures, the telescope's spectrographs began dissecting the light from individual stars within these early galaxies. And what they found in stellar nurseries 13 billion years in the past should have been chemically impossible. Imagine floating back to when the universe was just 300 million years old, peering into a stellar nursery where the first generation of stars should be igniting for the very first time. According to everything we know about stellar evolution, these primordial stars should be almost pure hydrogen and helium, the only elements the Big Bang produced in significant quantities. The periodic table of elements should be nearly empty. No carbon, no oxygen, no silicon, no iron. Just the universe's 2 simplest atoms slowly condensing under gravity's pull. But when Webb's instruments analyzed the spectrum of light from galaxy JWST 130, they found substantial oxygen. an element that can only be forged in the nuclear furnaces of massive stars and scattered across space when those stars explode as supernovae. This means the universe already had the raw materials to build rocky, potentially habitable planets, like Earth billions of years earlier, than our models say shouldn't have existed for cosmic ages to come. The discovery suggests this galaxy had been forming stars for potentially 100 million years before Webb observed it. Let me put that timeline problem in perspective. We're looking at a galaxy that existed just 300 million years after the Big Bang, yet it shows evidence of stellar evolution that should require multiple generations of star formation, stellar death, and chemical enrichment. It's like finding a library filled with Shakespeare in a civilization that just invented the alphabet last week. The oxygen discovery gets worse when you dig into the physics. Webb has found metallic iron dust and silicon carbide produced by aging stars, along with tiny clumps of carbon-based molecules, showing that even when the universe had only a fraction of today's heavy elements, stars and the interstellar medium could still forge solid dust grains. These are complex molecules that require not just one generation of stellar death, but entire cycles of stellar birth, evolution, death, and rebirth. Every spectroscopic analysis Webb completes reveals the same impossible pattern: chemical complexity, where there should be simplicity; stellar populations that have evolved through multiple generations, where there should be first-generation stars; and dust grain formation processes that require billions of years of stellar recycling compressed into the universe's first few 100 million years. If Webb's discoveries represent such a fundamental challenge to our cosmic models, why aren't they dominating headlines? Why aren't universities rewriting textbooks? Why does the astronomical community seem to be treating these paradigm-breaking findings as interesting footnotes rather than the revolutionary discoveries they clearly represent? The answer lies in the uncomfortable reality of how modern science actually operates. Institutionalized science tends to be hegemonic, with established theories and models holding significant power. New and alternative models face an uphill battle to gain acceptance within this system. The standard cosmological model, lambda cold dark matter, or NASA lambda CDM, essentially the textbook math that rules physics today, isn't just a theory. It's a multi-billion-dollar industry that employs thousands of researchers, drives funding decisions at NASA and the National Science Foundation, and forms the foundation of every cosmology textbook published in the last 3 decades. Consider the career structure of a cosmologist working in this system. Advancement depends on research output, publication record, grant acquisition success, and recognition within the scientific community. Your funding comes from grants that explicitly assume the standard model is correct. Your thesis advisor built their reputation defending Kraus Lambda CDM. Your future job prospects depend on senior faculty who spent decades developing the theories Webb is now systematically dismantling. Jacob Shen from MIT acknowledged the scale of the problem. There is a growing chasm between theory and observation related to the early universe, which presents compelling questions to be explored going forward. This isn't scientific caution. It's an acknowledgement from the inside that our fundamental models of cosmic evolution are breaking down under the weight of Webb's observations. When you submit a paper suggesting that Webb's observations require abandoning fundamental assumptions about cosmic evolution, you're not just challenging scientific theories, you're threatening an entire academic ecosystem. Challenging the foundational models of cosmology isn't just scientifically risky, it's career suicide. Proposing that our fundamental cosmological models are wrong is asking institutions to admit they've been allocating billions of dollars based on incorrect assumptions. That's not a conversation anyone wants to have during budget season. The pattern is historically familiar. Thomas Kuhn, in his work on the structure of scientific revolutions, explains that paradigms tend to be resistant to change until the old model's shortcomings become too significant to overlook. Only then does a paradigm shift occur, leading to the acceptance of new theories. We're watching this resistance play out in real time, as Webb continues to deliver observations that systematically contradict our cosmic timeline. 6 months after Webb revealed the impossible chemical complexity in ancient stellar nurseries, the telescope delivered its most devastating blow to cosmological orthodoxy. In 2025, astronomers discovered a rare, tightly packed collision of galaxies in the early universe. The newly discovered system, dubbed JWST's Quintet, shows 5 massive galaxies interacting within an unusually compact region of space and forming stars at a rate about 250 times the mass of the Sun per year. But here's what should have triggered a fundamental reckoning. This system is surrounded by a halo of oxygen-rich gas that lies outside the galaxies. The elements, such as oxygen, are only produced inside stars and were removed from the galaxies during the violent collision. The enrichment provides direct evidence that massive galaxy collisions were already actively shaping their surrounding environments in the young universe. Meanwhile, astronomers spotted what may be one of the universe's earliest barred spiral galaxies, a striking cosmic structure forming just 2 billion years after the Big Bang. The galaxy, Cosmos 74706, contains a stellar bar, a bright linear band of stars stretching across its center, similar to our own Milky Way. Stellar bars require billions of years of gravitational evolution to form. Finding them when the universe was still in its infancy suggests that gravitational physics was operating on drastically accelerated timescales in the early cosmos. The pattern emerging from Webb's observations isn't just challenging individual assumptions. It's systematically demolishing the entire framework of cosmic evolution. Yet cosmology textbooks remain unchanged. Graduate programs continue teaching the same models Webb has systematically disproven. The multi-billion-dollar infrastructure built around lambda cold dark matter continues operating as if these observations were minor footnotes. We're witnessing the real-time collapse of our fundamental understanding of cosmic evolution, met with institutional silence. The universe Webb is revealing isn't just different from what we expected. It's operating by rules we never wrote, following timelines we never imagined, and displaying complexity that suggests everything we thought we knew about the cosmos might be fundamentally, catastrophically wrong. Subscribe for more cosmic discoveries that challenge our models, and watch next.